Welcome to this screencast. And in the screencast, I'm pretty much just going to show you how to fill out these notes here. So we're going to look at graphing quadratics. So we're going to look at graphing quadratics. So the standard form of a quadratic is going to be ax squared plus bx plus c equals 0. And the name of this graph is going to be a parabola. And the parent function, the most basic parabola, is y equals x squared. And if we look at our table of values for this, using these numbers, it would be something like y equals 4, 1, 0, 1, and 4. And we can graph this over here, just like this, and connect them. And we can see that they form a nice parabola like that. And we can also see that it is symmetrical. So for all parabolas, if we find out one side, we automatically know the other. This is completely symmetrical. And we can also see that it has its center here, and then it goes over 1 and up 1, and then over 1 and up 3. And if we kept going, it would be over 1 and up 5, and then 7, and then 9. So we can use that pattern to graph it if we want to, but of course we can also always come back to this table of values. So once we know our parent function, we can use transformations in order to turn that into any of the other graphs. And we want to turn any formula, any quadratic, into the form of a times x minus h squared equals y minus k, because this is our vertex form, and this tells us that the vertex is going to be h, k, and that our scale factor is going to be 8. And now that scale factor, if we're looking at this pattern, it's going to multiply each of these differences by that scale factor. So here the difference is going to be 2, and then the difference is going to be 6, then it's going to be 10, and then 14, and so on. So that's how we can use the scale factor in the vertex to graph. But can we write all of our quadratic equations in this form? Absolutely. We just have to complete the square. Oh, I hope you guys could see what I was doing. I'll be more weary of that now. So when we complete the square, we have this. We have our a plus b squared equals a squared plus 2ab plus b squared. And we can remember that because we want to make our forms look like this so we can turn them into this, because that's similar to our vertex form. So comparing this as a squared plus 2ab plus b squared to this, we can see that we already have two squared terms. So we can maybe think about if x equals a, and then we compare these two terms, and we can think 2ab equals 6x. So we have 2ab equals 6x, and then if we simplify that to solve for b, we get b equals 6 over 2. So just half of this number. So we know that b is half of this coefficient in the middle when we just have x here. So b equals 6 over 2, or 3. And then, so if we add that to both sides, to add our b squared term, we'd have x squared plus 6x plus 3 squared equals y, and then plus 3 squared, because we add the plus 3 squared to both sides. And then we factor the left side to get x plus 3 squared equals y plus 9. And then we're in our form. We have our vertex is -3 and -9, and our scale factor is just simply 1. And then if we look at our table of values for that, we can see that we get when x is -3, y is -9, and just follow all those. And then if we graph those, we can get this nice parabola right here. And so that we see we have our center at -3 and -9. And so when I did this table of values, I just started there and got all on the left side, and then just did these two symmetrical points, because we know they're symmetrical. And then, so moving on, we have our next problem, and this one's a little more complicated because we do have this number here and we have this number here. But that's not too bad because we just have to make that first coefficient. We're just gonna make that first coefficient 1, and so we have x squared, and so we just divide it by 5. We divide everything by 5. So we just have everything by 5, and then we move this constant over to the other side because we're just gonna add that number here. We just want to start with 0 when we're adding the number, when we add the b squared. And then we remember that we just have to do this divided by 2 to get the b. So we complete the square and get x minus 3 over 5 squared equals y minus 7 over 5 plus that 3 over 5 squared. And then we just want to make the y coefficient 1 now. So we bring that 5 back over here, multiplying everything by 5, which when we simplify this, we get this negative 7. Simplify that out to get 9 over 5. And then we just finally simplify it into the final vertex form and get 5 times x minus 3 over 5 quantity squared equals y minus 26 over 5. And so looking at that, we see that our vertex is 3 over 5, 26 over 5. 3 over 5, 26 over 5. And that our scale factor is 5. So, oh, we didn't graph that one. That's too bad. But probably because it'd be too complicated, because we have our vertex of this fraction and our scale factor of 5. But that tells us all the information we need to know to graph it, and then we can just draw it. So to put this into a common form to make it much easier to graph, doing this with just the standard equation, the standard form of the parabola, ax squared plus bx plus c equals y, we would put the constant over here, move the c to this side, and then divide everything by a. And then, since we know that we need to do half of this, we know that this is a different b. I know it's a little confusing, but we know that that b is b over 2a. So we have x plus b over 2a squared equals y over a minus c over a plus b over 2a quantity squared. And we could simplify that, and then simplify that, and we could get this. And we don't have to worry about this side as much, because we can see that now we know the vertex is just negative b over 2a, if you're looking at this standard form. So we can come up here, and we can look at this, and see the vertex should just be negative 6 over 2 times 5, so negative 6 over 10. Simplify that to negative 3 over 5. And, this is what it was, negative b over 2a, so it should be 6 over 2 times 5, 3 over 5, which is what we got. And so that'll always work, so that's nice. And then once we get that number, we can just plug that into our original equation, and get our y. So it's just f of negative b over 2a. And our scale factor is just this a. It's just going to simplify to that. So we can use that information to do things much easier. So now if we look at that, we can see that our vertex is just going to be negative b over 2a. So it's going to be negative 8 divided by 2 times 4, divided by 2 times 2, which would be 4. So our vertex, our x value is just going to be negative 2. And then we plug that in, and we get 2 times negative 2 squared plus 8 times negative 2 plus 6. Do some calculator magic and get that it is negative 2. So our vertex is just negative 2, negative 2. Easy as that. We don't even have to complete the square. And then our scale factor is 2. And we can do our table of values and plug them in, and we can graph it. And you see our scale factor is 2. But it still looks like 1 and 3. Because a simple trick is if you change the scale on the graph to the scale factor, then you can just graph it like a normal parabola. And it's much easier. And so now we need to think about the maximums and the minimums. So the maximum is just going to be the highest point on the graph. And similarly, I bet you can guess what the minimum is. It's the lowest point on the graph. And then the x-intercepts, also pretty obvious, where the graph crosses the x-axis. And the y-intercept is just going to be where the graph crosses the y-axis. And you can think about the parabola, and when is it going to have a maximum and when is it going to have a minimum? Because when it's a positive parabola like that, it's going to keep going forever. So it's not really going to have a maximum. It's only going to have a minimum if it's a positive parabola and the scale factor is positive. And it's going to have a maximum if it's like that and the scale factor is negative. And so you can remember that. And the maximum minimum point, I mean, you're looking at this, it's just going to be the vertex. So we already know how to find it. We just have to know if it's a maximum or minimum. And it's just, if the scale factor is negative, it's going to be like this, so it has a maximum, and if it's positive, it's like this, so it has a negative. And we can find the intercepts. As you think about the graph, when it's like this, when you have your x and y axis, when it intercepts the x-axis, the x points are going to be something, but when it intercepts the x-axis, the y is 0. So the x-intercept is y equals 0, and then, so I bet you can guess the y-intercept is x equals 0. And so all we have to do is substitute those in the equation, and we can find them. So finding the y-intercept is super easy, because we just plug in 0 for x. So we get 7 times 0, we get 7 times 0 squared, plus 3 times 0, plus 2 equals y. Don't even need a calculator for this one. Y equals 2. So our y-intercept is going to be x is 0, y 2, 0, 2. And it's going to have a minimum or maximum. Well, it has a positive scale factor, so it's going to look something like that. So it's going to have a minimum. And we can remember, might as well find the point, is negative b over 2a. So it's going to be negative 3 over 14. And then do your calculator magic and get 47 over 28. And so that's our minimum point. That's also our vertex. And its maximum, of course, is just infinity because it goes on forever. And then for finding the x-intercepts, that one's a little more difficult. But if it's easy, we can use factoring. So if we have this, x squared plus 5x plus 6 equals y, we can factor that to x plus 2, x plus 3. We can solve both of those for 0, and we would get that x equals negative 3 and x equals negative 2. And since it's the x-intercept,